All right, so I added some more problems right here, more integration by parts, so we can just get a little bit more used to using them, using the process and going through it. And some of these ones are a little bit, they're a little bit more, maybe a little bit more complicated, but some of them aren't. And so you just, again, remember to keep it simple, silly. Uh, so we want to go through that, try them out, see how they go, and of course, as always. Um, Let me know if you have any questions. So, going to get started by going through, and I said we'd take a look back at that this one that I had gone through, and I said, okay, well let's make the e to the negative 3x. Let's make that be our u value, and the sine of 5x be the to be our v prime. This was my suggestion, right? Yes, that was my suggestion. Okay, so with that then, and then of course we went through and we looked at how the book did it with it being opposite, but I'm going to show you that this works out either way. It's very forgiving kind of problem. Most of them not so much, but that's kind of the nature of sine, of the sine cosine relationship as well as the e relationship. Um, how when you have e to a negative power, it's just going to alternate between back and forth, positive, negative, positive, negative, positive, negative. Sine, the sine, cosine, cosine, sine, cosine, cosine, off and on, off. So that's the idea. And so we're going to take a look at this and see how this all goes and how it all plays out and how it'll actually work out the same. So here we go. We take the derivative. We get negative 3 e to the negative 3x. And of course, if we integrate, find the antiderivative, you'd have to, it'd be a negative cosine of 5x, but, we'd have to deal with that 5, so 1/5. Okay? So we have that. All right, so then this would be, you have that negative 1/5 e to the negative 3x cosine of 5x, okay, minus, then the integral, and then we'd have this way. Now, negative, 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 three negatives make a negative, and we could take that 3/5 on out. And so now we're at e to the negative 3x cosine of 5x dx. All right, so now we're there, okay? And then we can do that yet again. And again, this time, again, we'll go with e to the negative 3x here. So that means negative 3 e to the negative 3x. And we'll go with cosine of 5x here. And so then this will be 1/5 sine of 5x. And this is kind of the idea, is we're getting, when we as we loop around here, that we end up with this deal right there going on. But this guy, obviously, that's one of the important things with these, is never ever forget to keep that, when you have to do it multiple times, do not forget this part, which can be very it kind of fades away because we get focused in on the integral, that we kind of forget about that part. But it's still all part of the integral, so we got to make sure we leave that around. This 3/5 is outside of everything, so we want to keep that out. All right, then we got these two guys, so that's 1/5 e to the negative 3x sine of 5x, and then we have a minus, and then, all right, so now this is minus that, and then we can take that negative 3/5 out, so that's going to be plus 3/5 on the outside, and then e to the negative 3x sine of 5x dx. And really the thing is with these ones, and now my head's in the way, so let me, come on, let's move this. So here, now I'm over there. All right, cool. All right, so now with this part right here, that's the key, because that is right there. And again, so now what we're going to do, though, is we're going to distribute in this negative 3/5 into here. So now we're got negative 1/5 e to the negative 3x cosine of 5x minus 3/25 e to the negative 3x sine of 5x, then minus 9/25 times the integral of e to the negative 3x sine of 5x dx. All right, so now I got that guy. But again, this is over here on the other side. So if we add this 9/5 or 9/25 times the integral to both sides, because we're solving for it. That's the idea. We want to be solving for that. And so we just treat it like that's our variable. So we add 9/25 times the integral of e to the negative 3x over here, sine of 5x. Add that to both sides. And so now we have one of them plus and 1, of course, 25 over 25. So we add those together and we get 36 over 25. No, 34 over 25. Come on. 34 over 25 e to the negative 3x sine of 5x dx equals negative 1 over 5 e to the negative 3x cosine of 5x minus 3/25 e to the negative 3x sine of 5x. And of course, you get that plus c always. And as always, plus c. So now, multiply both sides by that 25 over 34. And so we end up with the integral of e to the negative 3x sine of 5x dx. So we can reduce that. 25 divided by 5 is 5 times negative 1 is negative 5 over 34 e to the negative 3x cosine of 5x. This gives us negative 3 over 34 e to the negative 3x sine of 5x plus c. And so we get there, which then, if we were to take a look over at that, solution. There we are. And if we look right here, you can see negative 3 over 34, okay, e to the negative 3x sine of 5x minus 5 over 34 e to the negative 3x cosine of 5x plus c. And so that's the idea. And so this is the same thing. So sometimes with these, you just got to go through a little, and that one's pretty forgiving, which is really nice. It's really nice how forgiving that one was. All right. Let's just do something else. Okay. Some of these I ask you to prove something. And so what happens is I'm going to ask you to do 67, 69, 71. Those are all involved proofs. So let's go through with, say, 68. So 68 says x to the n cosine of x dx. All right, let's switch that over. All right, so this is 68. Okay, so 68 has this. And so we want to go through. And in this one, we have to use integration by parts because it's just cosine of x and that, cosine of x to the n plus 1. Excuse me, which would be really nice, but it's not. So we want to go through. We want to take a look at this. And we want to remember that the acronym to tell us which one to go first. So what should we make our u be? Let's make u equal x to the n. And then our v prime would be cosine of x. Well, that's part is probably easy. What do you think about that? Nx to the n minus 1. Okay, so then when we go through, this then would equal x to the n sine of x. Oh, not sine to the power of x, come on now. Minus the integral of n x to the n minus 1 sine of x dx. And then, of course, that n is just a number. N is for natural numbers, but n is just a number. So this is going to be x to the n sine of x minus n times x to the n minus 1 sine of x dx. And so this is just basically the idea is like, hey, you can actually memorize formulas for these. Which, hey, if you got time, you got brain cells to spare, which it seems like plenty of you think you do with all that lack of sleep that you're doing. According to one of my most intelligent former students ever. That's a weird way of putting that. So out of all my former students, one of the most intelligent ones ever shared with me that apparently if you get fewer than 6 hours of sleep, you start killing brain cells. So I've been working on that all week long, and it seems like some of you do too. So obviously those are ones to spare. So if you want, instead of killing them, you can use them to memorize these formulas. I mean, heck, that's something to do. But anyway, so here's a nice formula, and this is what we want to do. Is we want to get to that. We want to prove that, and that's what they want to do on these. Is we're going to do little proofs coming up with these formulas, and so these are just little formulas that we can do. And of course, as long as that is that x to the whatever power, basically we just want to go until that gets to 0 is what we want to do, and you can just keep on going until it gets to 0 is how we would go about that. So so try that out, and yeah, so let's give it a shot, and what the heck, let's just do another problem for kicks since I have your attention right now. Let's take a look at this memory model. Speaking of that, okay, so the model of the ability M of a child to memorize measured on a scale from 0 to 10 is given by this, where T is a child's age in years, and find the average value of this model. Ooh, average value. So, okay, all right, that was Joshua. All right, so you got excited about this. All right, so remember, average value. Got that integral, but going from 0 to 4, but it's 1 over 4 minus 0 of m of t dt. Okay, average value. So 1/4 times integral from 0 to 4 m. Here's a puppy. I got a puppy. Okay, just put it in the banking place. Okay. Like so. Okay. We could then, of course, split this apart so that way it's a little bit more manageable. So you just have that 1/4 out on the outside if you like. So we have 1/4. Well, actually, let's do it this way. I think this will work out best. 1/4, and then we have 1 going from 0 to 4 dt plus. Then when we take out that 1.6 on this part, 1.6, 1/4 of 1.6 is 0.4 times integral from 0 to 4 of t, natural log of t dt. Sweetness. Okay. So this one, again, we'd have 1/4 t squared over 2. Whoops, what am I talking about? 1/4 t. 1/4 t going from 0 to 4, which would end up being 1 plus. Okay, and then we have this one. We're going to want to use our parts here. So again, when we do these definite integrals, we want to do it off. We want to do the indefinite one off to the side. So we'll go over here. We're working in the Fermat space, or Fermat, whatever. Okay, so the integral of t, natural log of t, would equal, okay, obviously we want to make our u be the natural log of t. And so the first one, and so we got uv, so natural log of t, and that means that this would be t, so we got t squared over 2, and then we have 1 over t right on down there. So we'd have t squared over 2 times the natural log of t minus the integral we'd have t squared over 2 times 1 over t, which comes out to be t over 2 dt. And then this then would end up being t squared over 2, natural log of t, minus t squared over 4, okay, plus c in this case. But, so we'd take that, so that means we'd have t squared over 2, natural log of t, minus t squared over 4, going from 0 to 4. All right. Oh, whoops. All right. I'm like, wait a minute. We got a problem. That's an improper integral right there because there's an asymptote at 0. All right. So where did I make my mistake? Well, if you had the book open and you really quick looked, it said between the child's first and second birthdays to start off with. So, whoopsie. All right. So that means then, all right, so let's go back and adjust some of this. So everything was going great. That would also have been 0.4 right there. Everything was going super fantastic, okay, until I realized that we were talking about something and we go try to take the natural log of 0 and we got an issue with that tissue right there. So now, so that means then instead of going from 0 to 4, we're going from 1 to 2. This is 2 minus 1, which means that this is just 1. This is 2. This is 1. That's 1. This is 1. That's 2. This is not 1/4. That's just t. So that's 1 to 2, which means that, oh, hey, that's still 1. Cool. All right, so that's okay. All right, over here, instead of that being 1 point, because instead of doing the 1.6 divided by 4 to get that, that's just, so this is going to be 1.6 out here. So it's going to be 1.6 on out there. And instead of that going from 0 to 4, that's 1 to 2, 1 to 2. All right, cool. So we have 1.6. On the outside, we have 2 squared divided by 2 is 2. Natural log of 2 minus 1 minus, well, the natural log of 1 is 0. So 0 minus 1/4. All right, so now we have 1 plus 1.6 times 2 natural log of 2 minus 1 plus 1/4. All right, and that's just a big stinking mess. So, but that's what it would come out to be. So, yeah, so without a calculator, that's what we do. With a calculator, then who cares? Because why would we do integration by parts if we had a calculator, right? So, yeah, so we'd want to stop there. So, although, just so you know, there are, it kind of depends on the university, so or college. If moving forward, so in the future, just so you know, some universities, they are okay with graphing calculators. Some are not. Some are okay with scientific calculators, and some are not. So, you have such lame places like Harvard University where they'll let you use a graphing calculator, and other places such as some other higher educational places such as Cal State, Mount San Jacinto, no graphing calculators. So just some thoughts. So all right, try it out. If you let me know if you have any questions. Yes, it's a leaf. Joshua brought me a leaf. Where's